My electrolyte is chloride, and it is an anion, so that means it has a negative charge. It is usually attracted to potassium, sodium, and calcium. It is almost always near around following sodium, and that is because, like a little sister, little brother, your twin, I don't know, your best friend, they're always together because it makes table salt, so NaCl, table salt. And calcium has a really high extracellular fluid level, and this is because sodium is also on the outside of the cell, and then it goes in, but yes. So it has a really high extracellular fluid level. Chloride is really important when it comes to the formation of stomach acid, and this is because in your stomach you have to have a low acidity, low pH, compared to our blood, which needs to be around 7.4. We need like 3 to 4 pH level in our stomach, and so chloride binds to hydrogen, and that kind of keeps it at a good level, not too low, not too high, so it keeps it really consistent. And with the nephron loop, which is in our urinary system, when you go down to your descending loop kind of thing, and then you're ascending, so when you're descending, you always have your sodium getting filtered out of your filtrate and reabsorbed into your blood, and chloride also follows because there is high osmolarity of salt. So salt is NaCl. So it has a really high osmolarity. Medical terms for this, one of them is hypochloremia, which is a deficiency of chloride. So there's not enough chloride, and this can be caused to getting rid of too much. So like diarrhea, vomiting, excess sweating, and also chronic respiratory acidosis, meaning you have too much pH in your blood, so you're getting rid of too much stuff. Hyperchloremia is actually too much or an excess level of chloride, and this could be due to dehydration, so you don't have enough water, so it's a high osmolarity in your blood, and you need more water to kind of balance it out. Also too much saline, so like when you're in the hospital and you're injecting you with saline, like the little bag, you're getting too much, and that's not good.
Okay, so the electrolyte that I chose to talk about is sodium. In terms of major roles of sodium, it is one of the principal ions responsible for resting membrane potential. So when there is an inflow of sodium, the cell depolarizes, which we learned earlier in block 1. Sodium also supports nerve and muscle function throughout this process. In terms of excess and deficiency, imbalances with sodium are relatively rare, but when there is an excess of sodium, it's called hypernatremia, which is basically big and bloated, is how Dr. Yunt refers to it. So big and bloated, you'll oftentimes see water retention or edema, which is just swelling due to excess fluid. And when there's a deficiency, it is called hyponatremia, which, as Dr. Yunt calls it, is depressed and deflated. So this is when you could either lose large volumes of sweat or urine, and you replace it with just plain water instead of something such as electrolytes. And the physical symptoms would be the opposite of edema and swelling. So you could notice easily wrinkled skin or common symptoms of dehydration, stuff like that. In terms of how I remember sodium, I literally just think of it as salt. So if you eat a whole lot of salt or a big salty meal, you usually do feel big and bloated, almost gross. And if you don't eat enough salt or enough electrolytes, I guess you could remember it as, you usually feel just really sluggish, not full of energy, not enough, just energy boosting your body. So that's how I remember sodium and all of its functions.
My electrolyte was calcium. Calcium strengthens bones, regulates muscle contraction by activating troponin, regulates heart functioning, initiates blood clotting, and transmits messages in the nervous system by triggering exocytosis in the synapse. A deficiency of calcium is known as hypocalcemia, which results in muscle aches, osteoporosis, and neurological issues like memory loss. And a less common excess of calcium is known as hypercalcemia, which results in kidney failure, brittle bones, and digestive complications. A good way to remember the roles of calcium are 4 C's: clotting, contraction, communication, and cardiac.